Hello, this is the Unit 6 Mastery Assignment, Operations Logistics Management, Tesla. This presentation was put together by Jacob Burton for the Operations Logistics Management course taught by Professor Jackson at Southwestern College Professional Studies. Jumping right in this presentation, I'll talk about Tesla and how principles in Operations Logistics Management are relevant. I'll address the topics of process capacity, constraints, location, layout risk management, planning, scheduling, value forecasting, and lean operations. By paying close attention to the various concepts, Tesla produces some of the world's most advanced technologies at consistent quality and rate. There are multiple ways to evaluate Tesla's processes using processing analysis tools and techniques. The goal would be to systematically examine each stage of production, identify inefficiencies, measure performance, and assess alignment with Tesla's strategic goals. This means that Tesla should have identified key performance indicators for things that are critical to its operations. For example, Tesla should track the exact number of cars or batteries that it's producing within a given time and understand whether that number is acceptable. Tesla can use process charts to help it understand the different efforts that go into making its vehicles. Flow charts show the assembly process of its electric vehicles and batteries. Time function mapping helps Tesla understand how much time is associated with the different efforts that go into making its vehicles. Additionally, this can be further developed into value stream mapping, which helps an organization understand how to add value in the flow of material and information throughout the entire production process. This approach helps Tesla, or rather it allows Tesla to eliminate waste because it would highlight area of downtime in production or any delays in material handling. Moving along to capacity. So understanding capacity is critical for any organization that manufactures and delivers goods. Capacity is the throughput of a production system. To understand its effective capacity, Tesla would begin by identifying its current manufacturing output. They would need to gather data on a daily, monthly, and annual daily, monthly, and annual production rates for their vehicles, battery cells, and other energy products that they're manufacturing. Then they compare those the current output with their goals. This helps to identify whether current capacity aligns with Tesla's growth targets, or if they need to dive into their processes and determine the constraints that are having the largest impacts. One of the ways that Tesla minimizes impacts on its production capacity is by utilizing automation. The only way this would work is if automation could undertake tasks faster, more consistently, and more accurately than a human being. Okay, moving along to constraints. So Tesla's manufacturing process, it faces several constraints, including supply chain challenges, production scalability, technological challenges, quality control, regulatory compliance, and economic pressures. All those things play into constraints. Example, limited availability of critical raw materials like lithium and nickel, reliance on external suppliers, and logistical bottlenecks often disrupt operations. Scaling production requires significant capital investment and skilled labor, while introducing new technologies like the 4680 battery cells. That adds complexity and potential delays. Quality control issues arise as Tesla expands rapidly with customization options, further complicating production lines. Regulatory requirements and environmental concerns coupled with rising material costs and currency fluctuations add additional layers of difficulty. Localized challenges such as permitting delays or energy restrictions at specific factories further constrain operations. Despite all those hurdles, Tesla employs strategies like vertical integration and automation to mitigate the challenges and sustain their growth. Okay, location. By examining the different locations that Tesla uses to conduct its operations, it's pretty obvious that Tesla emphasizes a combination of factors when selecting its locations. The first factor is proximity to market. Tesla locates its factories close to major markets, which minimizes transportation costs, reduces lead times, and helps to streamline distribution. Example, the Berlin Gigafactory was established to serve the European market, while the Shanghai Gigafactory supports demand in China and other parts of Asia. Additionally, Tesla utilizes its direct-to-consumer sales, which relies on Tesla local distribution centers. The second factor is resource and supply chain accessibility. Tesla Gigafactories are intentionally located near essential materials. For example, the Nevada Gigafactory is close to the United States lithium mines. This reduces the cost of transportation and increases the security of supply for manufacturing batteries. A third factor is labor market and skill availability. Tesla's production facilities are located in regions where there is a strong pool of skilled workers. So Berlin, they're known for a highly skilled automotive and engineering workforce. Additionally, Tesla balances high-skilled labor with labor costs by locating facilities in China. The fourth factor is government incentives and regulatory considerations. By selecting locations where local government offer financial incentives, subsidies, or tax breaks for large-scale manufacturing, Tesla reduces its expenditures and operational costs. For example, the factory in Nevada was partly financed through state tax incentives. The fifth factor is sustainability and environmental factors. Tesla's gigafactories are in locations that align with its mission of sustainability. The gigafactories are designed to incorporate solar panels, energy storage, and other renewable energy source solutions to reduce carbon emissions and energy costs. Okay, moving on to layout inventory management. So in addition to choosing location strategies that help minimize costs and maximize revenue, Tesla employs multiple strategies within its production facilities that optimize the manufacturing process. A repetitive and product-oriented layout is ideal when producing high-volume, low-variety products, either through the means of fabrication line or assembly line. So this means that it's a perfect fit for factories that are going to produce thousands of cars or batteries per week. Tesla's factories follow a product-oriented layout, organized equipment and workstations in a linear path based on the sequence of the production process. Tesla also uses a fixed position layout for large components. A fixed position layout is a project that remains in one place. The workers and the equipment come to that one area to work, for example. Tesla's larger components that are difficult to move, battery packs, stay in position while the workers and equipment are brought to the packs. This ensures safe handling of the battery packs while allowing workers to still be precise with their work. For areas focused on component production, like motor or electronics assembly, Tesla uses a cellular layout. The cellular layout is a setup where workstations are arranged in cells, allowing specific components to be produced and tested independently before being assembled into the main product. This approach helps Tesla reduce production time and improve quality control before being integrated into the larger product. A cellular layout also allows for an organization to adapt to changes in production demand, as they are able to reassign resources within their cells or even reconfigure cells for different tasks. Okay, planning. Tesla employs a structured planning process that incorporates short-term, mid-term, and long-term strategies to align its operations with ambitious growth and sustainability goals. This process integrates data-driven decision-making, market analysis, and resource allocation to achieve specific outcomes. Short-term planning focuses on immediate operational needs, typically within a year. For Tesla, this involves optimizing production and logistics for current vehicle models. Midterm planning spans 1 to 3 years and involves scaling operations or launching new initiatives to meet market demand. For example, Tesla's decision to expand gigafactories in Shanghai and Berlin exemplifies midterm planning. These facilities were strategically positioned to meet growing demand in Asia and Europe. The construction and operational ramp-up, typically a multi-year process, were planned to ensure seamless integration into Tesla's global supply chain while meeting regional regulations and customer expectations. Long-term planning encompasses strategies and goals that span 5 years or more, focusing on innovation, sustainability, global expansion. Tesla's long-term goal of reducing battery costs by introducing the 4680 battery cell technology reflects its planning horizon. This innovation involves redesigning the battery structure to enhance performance while reducing production costs. The company plans to integrate this technology across its product line over the next decade, supporting its mission to make electric vehicles more affordable and sustainable. All right, scheduling. Tesla leverages advanced scheduling concepts to optimize its manufacturing and delivery processes, ensuring efficiency and alignment with demand. Key scheduling strategies include real-time adaptability, synchronization across global operations, and integration of data analytics. Tesla uses just-in-time scheduling to minimize inventory costs and streamline production. This approach ensures that materials and components arrive at manufacturing facilities precisely when needed, reducing storage requirements and waste. Tesla gigafactories, which are designed for high efficiency, rely on just-in-time scheduling to coordinate the flow of raw materials and parts. Tesla integrates real-time data analytics to dynamically adjust production schedules based on demand fluctuations, supply chain disruptions, or labor availability. Advanced algorithms forecast production needs and optimize resource allocation, allowing Tesla to quickly respond to changing market conditions. For example, during the COVID-19 pandemic, Tesla adapted its schedules to manage supply chain bottlenecks while maintaining output. Okay, moving along to value of forecasting. Forecasting can provide Tesla with a wide range of benefits by enabling the company to anticipate market trends, optimize operations, and maintain its competitive edge. By implementing forecasting strategy, Tesla could improve its demand forecasting, supply chain optimization, financial planning, innovation and R&D planning, and expansion and gigafactory planning. Through demand forecasting, Tesla can predict future sales of its vehicles and energy products across various regions using historical data and market trends to align production schedules and inventory levels. This minimizes the risk of overproduction or underproduction. Supply chain optimization is another key benefit, as forecasting allows Tesla to anticipate the need for critical raw materials like lithium and nickel, reducing the likelihood of supply shortages or disruptions. Financial forecasting plays a vital role in helping Tesla estimate revenues, manage operational expenses, and allocate resources for strategic investments in technology and facilities. Additionally, forecasting aids in innovation and R&D planning by identifying emerging trends in electric vehicles, renewable energy, and autonomous technology. This helps Tesla prioritize research initiatives that align with market demands, ensure that the company remains at the forefront of innovation. Tesla also leverages forecasting to assess market potential for expansion and determine the feasibility of building new gigafactories. By analyzing factors such as regional demand, regulatory environments, and infrastructure availability, the company can make informed decisions to minimize risk and maximize returns. These forecasting strategies collectively empower Tesla to maintain operational efficiency, drive growth, and sustain its leadership in the electric vehicle market. So, lean operations. So, if they're not already doing this, which they pretty much are, but implementing lean operations at Tesla could bring several benefits to the company, helping it streamline production, reduce waste, and increase overall efficiency. So that's the idea of lean operations. By incorporating lean principles into its operations, Tesla could reduce production costs, improve quality control, deliver products to the market quicker, have more flexible production, and enhance supply chain efficiency. Lean principles focus on minimizing waste in all of its forms. So, example, overproduction, excess inventory, waiting time, and defects. By applying these principles, Tesla could further reduce unnecessary costs in its manufacturing processes, improving its profit margins. Lean emphasizes continuous improvement and quality at every step of the process. By identifying and eliminating defects early in the production process, Tesla could improve the reliability and quality of its vehicles, enhancing customer satisfaction and reducing warranty costs. Lean principles advocate for eliminating bottlenecks and improving flow. Tesla could improve its production speed and reduce the lead time from design to delivery, allowing the company to respond faster to market demands and changes while also meeting delivery deadlines more consistently. Lean operations can make Tesla's production lines more adaptable. With improved flexibility, Tesla could shift production more efficiently between different models or even introduce new models faster in response to consumer demands or market conditions. Lean also focuses on just-in-time inventory management, which minimizes the need to hold large inventories. So by working closely with suppliers, Tesla could reduce supply chain costs, improve inventory management, and avoid overstocking or stockouts. By implementing lean operations, Tesla could further enhance its competitive edge, increase profitability, and better meet the growing demand for its electric vehicles. In conclusion, Tesla incorporates many aspects of operations, logistics management, process, capacity constraints, location, layout risk management, planning, scheduling, the value of forecasting, and lean operations bring significant advantages to Tesla in its ability to compete with other automotive manufacturers. Here are the references that I used to inform this project. Thanks.